started recording. So I'm Nilakanmani. Let me introduce myself. I'm Nilakanmani. I'm one of the PMRF NPTEL TAs for this course Characterization of Construction Materials. So weekly we'll be having 3 live sessions. One on Monday, Tuesday, and on Friday. So usually I'll handle on Monday's live sessions, but due to some works we exchange our live session slots. So in this session we'll be handling few problems from the particular week content. By this week we would have by today we would have handled week 2 content, but unfortunately teaching you week 1 content questions. So from next week we'll try to correct this, and then we'll see the current which you are going to submit. We'll discuss the type of questions there. Okay, so let me go to the PPT. Before that, I hope everyone knows how to answer questions from polls. So if for the new people who have joined today, let me help you guys. I hope you can see my screen. So once you uh, let me teach you how to answer questions from polls. Okay. So to the bottom right corner of your screen, there's an option called activities. Okay. Near to host control, next to activities. If you click that, you'll find 4 different options. Out of that, you have to click polls. If you click that, you can find about 9 questions already launched. Okay, so question 1 till question 10 will be there. So once we discuss the questions here from the PPT, you can simultaneously go and give your answers in the polls. So by that time, I'll get to know how many of you are able to give the right answer, or else we'll discuss on the particular question, or else we can skip to the next question if everyone knows the answer. Okay. So, but don't answer all the questions at a stretch. Wait till we discuss the question, then you give your answer. Okay. So now, and if you're using mobile phone, there will be 3 dots in your screen. If you click that, I think you can get to the option polls. Okay. Let me get back to the PPT. So here is the question 1. So here, this particular week 1 content is about an overview to construction materials. So in that, C3S, tricalcium silicate is responsible what? And then C2S, dicalcium silicate is responsible for what? So we have given here options, either ultimate strength or early strength. You have to find the right one and give your answer. Let me start a timer for a minute. Then we'll discuss the answer. Please give your answer in polls. If not possible, let us give your answer in chat box. Time is up to see the solution. So here in the particular slide from the lecture, we can see that C3 is responsible for setting an early strength, and C3 is responsible for early strength gain, and C2 is responsible for the ultimate strength gain, for the later age strength. So the correct answer is nothing but option B. So now let's move to the next question and see the polls response a bit later. Moving to question number 2. This is a very simple question. The fineness of typical Portland cement is. Let me start a timer for 30 seconds. It's a very simple question. What is the fineness of Portland cement? Time is up. So let's see the solution. Answer is nothing but 300 to 350 meters square per kg. So answer is option A. So now let's see what's your answers from polls. Okay, most have given the right answer. Okay, fine. Now let's move to question number 3. So it's a match the following questions. You have to type your answer in the chat box. Okay. So you have to find out which of the reaction products. Here we have different reaction products. Either calcium silicate hydrate and calcium hydroxide and calcium sulfoaluminate. So you have to find out which of the reaction products is responsible for the following properties here or performance, which is responsible for that. Okay. So let me start the timer for a minute. Here the reaction products are calcium silicate hydrate, CSH, and then calcium hydroxide and calcium sulfoaluminate, which is nothing but etringate and monosulfate phases. So which is responsible for toughness, primary strength, which is susceptible to chemical attack, and which is responsible for early stiffening. You have to find the correct on. You have to match the correct answers and then put them in the chat box. Time is up. Let's see the response. Okay. Only one people have given the answer. Okay, fine. Let's discuss the answer for this problem. So, here first one, calcium silicate hydrate is the major binding phase here compared to other phases. So it gives a primary strength, okay, which is the binding phase mainly. And then coming to calcium hydroxide, we all know that it is easily susceptible to chemical attack, which because we normally encourage adding pozzolanic additive so that the additional calcium hydroxide will react with the pozzolanic material and form additional CSH so that we can avoid the chemical attack part. We can prevent the concrete from chemical attack. Okay, so now the third one is calcium sulfoaluminate, which is responsible for the early stiffening because we know that etringate phase is primarily responsible for the early stiffening of the cement concrete. Okay, so now if you guys have any doubt in between, you can stop me by any time. We can discuss even if it's not related to the particular question or similar type of question. You can stop me by any point of time and we can discuss. Okay. Now let me move to question number 4. Question number 4 is cracked asphalt. We know that we have different types of bitumen here: natural bitumen, artificial bitumen, and cracked asphalt is the artificial bitumen, and which is obtained from a particular process. Which of the following process? Either it is from fractional distillation or destructive distillation or mining and heating. Okay, so let me start the timer for a minute. After a minute, we'll see the solution. So the people who join you, please give your answer for the current question in chat box or even in polls. Time is up. So let's see the correct answer. So here we know that as discussed, there are different types of bitumen: natural bitumen, artificial bitumen. In artificial bitumen, cracked asphalt is one of the types, and it is manufactured by destructive distillation. It is produced by the process called destructive distillation, in which a solid particle will be subjected to decomposition on heating. From that, we'll cracked asphalt. Okay, so from here the correct answer is nothing but option B. Let me see how many of you have given the right answer. Okay, fine. It's okay. Okay, now I guess you all got the right answer. So now moving to question number 5. So here this question also from a bitumen binder. So which is this is not used as a binder in pavement construction, but used for waterproofing and pavement treatments. Okay, so which of the following is not used as a binder in pavement, but used as a waterproofing and pavement treatments? Okay, so let me start the timer for 30 seconds. Please give your answer in polls and chat box. And if you guys could not follow up the class, you can stop me by any point of time. We can discuss. Time is up. Let's see the correct answer. Correct answer is they have here in this snap is particularly from the lecture. So here they distinguish both asphalt and tar. So in which asphalt is used as a binder in pavement construction, but tar is used for waterproofing and pavement treatments. Okay. So the correct answer is nothing but tar. So now moving to next question. So which of the following techniques are not used for reducing viscosity of asphalt? So in the lecture, Professor detailedly explain about which of the following methods are used for reducing viscosity of asphalt, because we need to when asphalt is used for road construction, we have to reduce the viscosity so that it can easily flow. So which of the following techniques can be used for increasing the which can be used to reduce the viscosity of asphalt? So let me start a timer for a minute. Please give your answer in polls or even chat box. We'll see the answer once the timer is done. Time is up. Let's see the solution. Coming to asphalt properties, we know that asphalt is highly viscous in room temperature, so we have to reduce the viscosity to practically use in pavement construction. So normally we heat the asphalt, that is the generally used technique to reduce the viscosity, lower the viscosity, and we can even make it as an emulsion with water, or we can dissolve it in organic solvent and dissolve it. Okay, so which is not use nothing but reducing the temperature. Reducing the temperature will further increase the viscosity. So let's see what response you guys have given in the polls. All right. Okay. Some people have thought that it is not used for reducing viscosity. Okay. It's fine. Very simple to get confused. Okay. So moving to question number 7. I hope you guys got it right now. Or we can, which are the following things are not used. Okay. It's not which is used. So now the question number 7 is excess free lime in ordinary Portland cement. We know that free lime can be in ordinary Portland cement if it's not properly a proper quality control is not done. They can be free lime in ordinary Portland cement, which can cause increase in compressive strength or prolonged final setting time, unsoundness of cement, and then lower heat of hydration. Which of the following can be caused due to excess preamine ordinary potassium? Let me start the timer for 30 seconds. Please give your answers.
Excuse me, ma'am. Can
Yeah.
you please can you please share this PPT in the NPTEL portal?
Actually, we do that. Uh, Maybe this is the first week, right? Soon you it will not be in the portal,
Mm,
but we load this videos in YouTube. You guys will get the link for the YouTube link. From there, maybe you can get collect the PPTs. I think NPTEL should give you link for this PPTs. That is there, I guess. I normally share with the YouTube video. I have the link for the PPT also.
okay, ma'am. Thank you.
Yeah, sure. Thank you. So the correct answer is nothing but unsoundness of cement. You know that free lime is there. We normally check for free lime by soundness test and check whether free lime is there or not. And we use lime saturation factor uh, to check whether free lime is there in OPC cement or not. Okay. So now moving to question number 8. This is the assertion reasoning type of question. Before that, let me check your response from polls. Okay, most of you given the right answer. Fine. Let me move to question number 8 now. So the statement assertion nothing but gradation of aggregates is more important in asphalt concrete than in Portland cement concrete. The reasoning given is asphalt just provides a medium to bind the aggregate. Strength and stability are function of aggregate interlocking. Okay, this is the assertion and reasoning. So you have to find if you you have to choose the right answer here. Like if you feel assertion and reasoning are true, then and if you find the reasoning is have put here have put given reasoning as R here. If you find R is a proper reasoning for assertion, then you can pick option E. Similarly, if it's not a proper reasoning but both are true, then you can pick option B. Like that, you can read out the statements and assertion reasoning and pick the correct statement. Okay, pick the correct answer. Let me start the timer now. Time is up. You see the correct answer. Answer is nothing but both assertion reasoning are true and R is a proper reasoning for assertion. Okay, and it's directly from the lecture PPT actually, this question. So let's see the polls response now. Okay, some of you felt the reasoning is false. Okay, fine. Because asphalt doesn't provide any strength by itself actually. It's just a medium to bind the aggregates and the strength is mainly from the aggregate interlocking part and not from asphalt part. Okay, so now let's get back to the PPT. So now the question is from failure mode in asphalt concrete. So the statement is rutting is a mode of failure in asphalt concrete which is due to increase in brittleness at low temperature. Okay. So first is nothing but a statement. Rutting is a mode of failure in asphalt concrete and which are explaining which is due to increase in brittleness at low temperature. Please pick whether it's true or false. Let me start the timer now. Time is up. The correct answer is rutting is nothing but rutting is a mode of failure. That is correct. But rutting is nothing but accumulation of permanent deformation in the wheel part, typically a hot weather problem. So rutting is not due to increase in bitterness at low temperature. Okay, so the correct answer is false. Let's see what is the response from polls. Okay, nice. So moving to question number 10. So in this thing I've discussed about shrinkage. So which of the following case will crack on shrinkage? Consider both case 1, case 2 or concrete samples. So which of the following case will crack on shrinkage? That is the question. So here in case 1, you can understand that this thing drawn on the sides indicates restraint. Okay, so case 1 is restraint on one side and case 2 is restraint on both the sides. So which of the following case will crack on shrinkage? Okay, either case 1 or case 2 or both case 1, case 2, none of the cases will crack on shrinkage. Let me start the timer for a minute. And if you know the answer why and which case will shrink or which case may not shrink, and if you know the answer, please type it in the uh, chat box. After giving your answer in polls, please type your answer in chat box. Time is up. Let's see your response in polls. Okay. Some of you think both case 1, case 2 will crack. Okay. Some of you pick case 2. Okay. Let me see the chat box. Okay. None of you have posted the reason. Okay, fine. Let's discuss the problem. So here, if you pick case 2, if you like someone can unmute and explain why you think case 2 will uh, shrink. Case 2 is the right answer, but can someone unmute and explain why case 2 will shrink? Yeah, you can do it. Come on. Am I audible to all? Is my voice feeble? No sound at all. About 6 to 7 people are in class, I guess. Okay.
Then because in case 2 the specimen is restrained,
Yeah.
so when the shrinkage will occur, the restraints will not allow it to shrink, and then the crack will occur,
Yeah.
which is not in case.
What if there is a reinforcement in that case? Will it crack?
In case one,
What if there is a reinforcement in there?
reinforcement.
Yeah, if there is a rebar there in between here, let's assume like let me draw it here. Yeah, if there's a rebar here,
Maybe crack, but the extent of crack will be lower than the uh, when there will be no reinforcement.
okay. What if there are some fibers here? Fiber reinforced concrete is there.
And so fibers will take the impact, and it will not crack, or there will be something like that.
Okay, fine. Let me explain. Thank you so much. What is your name?
Ma'am, Sris.
Sorry,
Sris.
Streets. Okay, thank you, Streets. Thank you so much. You can mute now. Thank you so much. So, uh, try to be attentive in class, or else it's like I'm speaking to the laptop and there is no response. It's very weird to talk in front of laptop. Yeah. So, getting back to the problem. So, if there, as you all understood, in case two, there is restraint on both the sides. When there is restraint, if there is some shrinkage in volume, there is reduction in volume. If there is no restraint to it, automatically there will be no cracks. Why there will be cracks? But if there is a restraint to the to the shrinkage happening, the reduction volume, then there will be cracks because of the restraint provided. And if there is a reinforcement, what happens actually when the volume shrinks? The concrete will be subjected to tension, right? In that case, if you provide a rebar, then it will help with the tensile capacity of the concrete itself. So it might reduce the impact. But if there is a fiber there in the system, then uh, uh, if after the first crack is happening, the fibers will try to bridge the cracks. So in that cases, it will also help with the concrete from cracking. Okay, but it is assumed that after the first crack is opening, then only the fibers try to bridge the cracks. Okay, so this is the last question for the day. So hereafter, I don't have any questions particularly. If you have any queries from week one or week two or till whatever is posted, you can ask me now. I can help you with the any queries. Okay, is there any query from week one, week two, or week three? No queries at all. You can even type in the chat box. No one is willing to post questions. Yeah, yes,
Ma'am,
Sri. Yeah,
I have a question that we we have taught about the TMT and QST bar,
yeah.
and both are same, or means they are different in nature.
Okay. Like normally in market it is called as TMT rebars. Okay. But actually more in many cases it's thermomechanically treated bars. All the rebars are thermomechanically treated. Then why we have to set as TMT rebar? That is the question posted. So if you say QST, I think uh, quenched. I forget the full form as all of a sudden. Wait. Yeah, quenched self-tempered rebars. That is the that is the correct name because quenched and self-tempered means uh, it is quenched and it is self-tempered uh, to have better performance. That is why we say it as QST more than TMT. If you take any rebar in case, it will be thermomechanically treated. Then why you have to set as TMT for the particular rebar? Quenched and self-tempered will be even more better to represent the particular rebar. It will be a proper name. You got it or
Ma'am, In the lecture we have seen that when we get the QST, we get pearlite, ferrite pearlite inside in the core
Yeah,
and tempered
yeah,
martensite
yeah,
in the
yes,
outer surface.
yeah,
But when I taken the basic construction material course last time, the
yeah.
TMT we have taught, it was same as that of QST.
Uh, you're saying that TMT bar also has this pearlet and martensite, but why you have to say it as QST? That is your question, right?
Yes, ma'am.
Actually, both TMT and QST are same. Okay, but if you take any rebar, it will be thermomechanically treated, right? It will be taken to high temperature and it will be mechanically treated. Then only you can use the rebar. Okay. In if you take any rebar in case, it will be thermomechanically treated. But why we have to say about that rebar as TMT? Using QST will be even more appropriate to call it. It will be a better name. It's about how we call it, not about the difference. It's not different. Both are same. How we are calling is the difference. How we are naming it, that is the difference. Yeah, TMT bar or QST bar both will both are same. It will have perlite inside and martensite on the outer side for better it will for better hardness.
So we can say that both are the only processes, different processes
No,
of
no, both are same. How to say it?
processes of manufacturing.
Both are same. Like we are having two names for it. Okay, in market is called as TMT, thermomechanically treated. But the correct name to call it, TMT is not a correct name to call the rebar, whatever we use it. QS will be the more appropriate name. How to say it? Maybe if we say this is a glass, right? But it any glass, like any shape of this, we can call it as a glass. But if saying it is a steel uh, tumbler will be a correct name, right? I don't know. Yeah. Yeah, like TMT is like glass, but if you say it is a steel tumbler, it will be even more appropriate to call it.
Okay,
Both
ma'am.
are same. Both are same, but the way we call it is not the appropriate way to how we call it. That's it. It's about the naming issue, not about the steel or anything.
Okay, ma'am.
Yeah. Any other query? Even from week one, you guys have submitted assignment. If you have, but we can't discuss exactly the current assignment questions, but we can discuss the problem or concept behind that. Okay, what do you guys expect from my side? Like, are you guys all from BTech or MTech background or PhD scholars?
Research scholar, ma'am.
Research scholar. Okay, everyone here is research scholars.
BTech, ma'am.
BTech. Okay, fine. Okay. So I know that for a PhD scholar, this kind of questions will be very simple, but for a BTech student, this might be okay question. So it's difficult to create a question bank for everyone in the room here. So let me try to take proper questions from next week, because the characterization techniques what we are going to discuss will be from next week. We'll start like from calorimetry and followed by high sophisticated techniques. We'll discuss from next week. If you guys expect something from our side, you can discuss here. We can include that in our lecture PPT. We'll try to include it in the problem solving session.
Ma'am, is this sections is will be there only for the NPTEL exam? These sections will be there.
These sections, in the sense, totally we have week 12, 12 week of content only
And
from the
this
content.
live this live section content will only be from the exams. Exam point of view are these exact sessions.
Actually, we are taking current assignment problems in our hand, and then we are taking similar type of questions and we are posting here. This is not for a part of final exam or something like that, but we are helping you to understand the concepts even more better so that you can submit your uh, current assignments properly. Like without,
Okay.
you can have better understanding, so that you can able to help, we can help you guys so that you can submit the current assignments, and you can also attempt the final exams. It will be like, it's kind of a help and support.
Okay, ma'am.
Totally, we have only 3 live sessions for NPTEL course, for a 12-week course. So in that case, having a uh, having live sessions every week will help the students to perform better. That's the agenda. Yeah. Do you guys have any expectation from our side? Like, what do you expect out of this live sessions? We are here to discuss problems on the particular week. No more expectations. Okay. Yeah, 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 Meena.
Ma'am, please look into the last date submission for the coming assignments,
Yeah, let
because
me.
week two assignment has,
Okay.
so just after submitting, this discussion is coming like that. It is
Yeah, even I feel it's not right, right, like it is not helping, I feel. So before
because
last time,
after submitting, we are getting knowing the discussion forum is open.
yeah, 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 I can understand that. Yeah, let me try to speak with the NPTEL team and get back to you guys. Yeah,
Okay.
sure. I'll help in that regard. Yeah, I'll discuss.
Okay.
Any other query? Okay, then if no more queries, we can wind up the class here. And if you have any expectation, you can even post it in the discussion forum. If you
Hello,
have, yeah, 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 Digambar.
ma'am. I'm BTech civil engineer student.
Yeah, yes.
Uh, 7 सेम अभी
Okay,
एग्जाम हुई है।
okay.
मैडम हिंदी समझ में आता है क्या?
No, no, no Hindi, please. I'm okay with English.
Uh,
Yeah, yeah.
yes, this is a 7 सेम और ये ऑनलाइन कोर्स will be next सेम
You're asking about the
and
exam date.
class start will be exam and submission day.
These dates will be available in NPTEL forum itself. Mostly you guys have exams on April month.
Yes, ma'am, but uh, it's a class timing and submission and exam not at the time attend.
Actually, I could not understand you clearly. If you have any query, if you are able to type, you can type. Like, or else, like you want, you're not able to submit the assignments on time. That is your concern.
It's a,
Digambar, can you come aside and speak?
thank you, madam.
Okay. Okay. If you have any queries, you can post in the discussion forum. We are free to like, we'll address your queries at on daily basis. We'll try to answer your queries. If not, at least we'll repeat it at once in 2 days. We'll answer your queries. Mostly we'll try to answer queries in a day. Okay then. I think we can wind up the class here. I don't want to take your time, eat your time. Okay then. If you have any expectations out of this class, you can post it in the discussion forum, or you can tell me now. Yeah. Thank you so much. Thank you for being so patient until the, for this week. From next week, from Monday and Tuesday, you'll have questions from week one content. Sorry, week two content. Yeah. Thank you all.
thank you, ma'am.
Thank you.